если человек знает Kubernetes, 90% он поймет, что такое OpenShift. А некоторые просто и пользуются OpenShift, как Kubernetes, и хотят вообще не пробовать ничего, что OpenShift дается. Так тоже можно.
Welcome everybody to this wonderful meetup event thing. I'm not sure whether it's a meetup or an event or what. For us, we're the cloud native team at Synopsys. So for this is like one of our meetups, and we were graciously invited here by opsgenie and everybody else who is putting this event on. So thanks. My name's Jay, and this is the rest of the team. Jonathan Beakley. Up there, he runs the show. Matt, Rob Rati, and Senthil on the slides over there. So that's who we are. Jonathan, Rob, me, Jay, Matt, Senthil. We got some test ops people in here, Joel and Joyce, help us ship stuff. We do a lot of stuff. We do a lot of the engineering behind the Blackduck's SaaS, which runs using an operator model. We've got the offsite connector, which we're going to talk about, scans everything in your cluster, finds vulnerabilities automatically, and scales horizontally. We're going to talk a lot about that in a new release that's just maybe a few days away. We've got the Blackduck Operator we'll talk about, which is based on an open source project called Perceptor, alliances, and we do some upstream Kubernetes and OpenShift stuff. Not a lot of code anymore, but me and Rob came from that world when we started this team a while back. Next slide, please. Sorry. YAML is not software. I'm going to go fast because we got a demo we want to do. So that's the theme here. You can't just ship YAML. We all know about how many of you guys use Kubernetes? Okay, 1, 2, 3, I can't count, okay, whatever. YAML is not software. We had a big problem shipping YAML to customers. Customers, like, they don't know how to type sometimes. They don't know how to set variables. They don't know how Kubernetes works. It's a mess. And you've got to ship your software. You still have to ship software somehow. That technology doesn't take that out of the equation. Upper right, you've got an old RPM script. How many of you guys have written an RPM file or used RPM-based software? Okay. Do any of you feel like it's easier to install an RPM than to install a Kubernetes app? Okay, I do. Because I just do RPM install and it kind of works. Okay. So I'm surprised nobody raised their hand. Anyways, so Helm kind of makes it easier, right? But not everybody runs Helm. Every Linux distribution has a package manager. Not every Kubernetes distribution has a package manager. And there's issues with Helm. Obviously, it has to run as root across your cluster. It's got all these privileges. Not everybody wants it. And so, next slide, please. Quick overview of what's out there for orchestration. So that's what we're going to talk about, right? Like, how are you shipping applications to customers? And then we're going to, like, brag about how the Blackduck Operator works and how we ship to customers post 2.1 release. There's Helm, which we just talked about. There's things like Short, OpenShift templates, Ksonnet. Have any of you guys heard of any of this stuff? Templating languages? Okay. So all that stuff is super powerful, especially for developers. None of it solves the packaging problem entirely, though, right? So, but it does make your life easier in different ways. The OpenShift template over here on the bottom left, process, that's been around for a long time. That's an easy way to substitute parameters. Heptio's been innovating a lot with Ksonnet, and the nice thing about Ksonnet is you can almost like build up your own DSL and inject things with reasonable defaults into your YAML spec and everything. And of course, there's CRDs. Does anybody know what a custom resource description is? Okay, some of you guys. So the beautiful thing about a custom resource description is it decouples defining the high-level stuff about your application the customer's going to care about from how you implement installing that application on the cluster. And once you get that decoupling, you can really iterate in a very organic, natural way towards a higher-level installation process. Controllers and operators are the second half of that story, right? So, but they're hard to write. So, next slide. All right, so this is what your developers want, right? Developers in a cloud native world, the reason this stuff is taken off is because There was no rules in Kubernetes, so developers could do whatever they wanted to. So my PSA here is, if you adopted Kube for feature velocity and you're making it impossible for anyone to do anything on your Kubernetes cluster, then you're wasting your time. You might as well go back to VMs. Okay, make it easy for your developers to use Kubernetes, to innovate, to build new things. And some of this stuff in red is controversial, right? But I think applications should get TLS for free. They shouldn't have to worry about it. It should be layered in. You can use things like Istio for that. And I think applications should get storage for free. That's a hard thing to do. We can talk about why later. You can't always rely on all storage systems using PVCs and whatnot. But so let's keep going. Okay, so my friend Rob Rati built an abstraction layer. As I said, operators are hard to build. The beautiful thing about an operator, though, is you can do anything with them, and you can take advantage of everything that's on that last slide. On the left was this hacked up V0 version of our, essentially what is now the Blackduck operator. You can see it's hierarchical, the syntax is really complicated. It's kind of disgusting. Most developers, unless they knew Kubernetes and worked on Kubernetes, probably wouldn't even be able to write something like that, and it's actually worse than that. If you want to encode cloud-native terminology into your application. And the beauty of this is you don't need YAML anymore, so the compiler enforces it for you. But on the right is our Horizon library, and you can see how it's flat. And Rob, you want to talk a little bit about, through the next couple of slides, on why we built Horizon. It's easy.
So kind of as Jay was talking about, a lot of the problems we had with shipping YAML to customers, they weren't very good at editing YAML, right? And almost all of your applications, at least our applications, needed some level of customization, which means we couldn't just ship YAMLs that would work on all customers. So customers had to edit them, and then we spent a whole bunch of time coaching through YAML. It should be a simple syntax, but it's not as clear-cut to a lot of people as it seems like it would be. So what we did is we wrote Horizon, right? And Horizon abstracts out all the knowledge of all the Kubernetes syntax. You don't have to know anything about Kubernetes syntax to write your application. Additionally, it's a library, so you can vendor it in to your own thing, right? And now you have the ability to ask questions to your user. How much memory do you want, right? How many CPUs do you want, right, for your thing? It provides a means to get back to something where you're not editing a file and relying on some syntax and having to know the syntax. Now you can ask questions through an application in clear text. Make it easy for your users to customize your application. It's all flat, right? So we have Protoform, it's all open source, it's using this. Horizon also supports operators. You can set controllers in it when you're deploying. So it's the foundation for everything that we've built with Protoform. Right now we're using it in OffSite. We got the Blackduck operators, and we got Blackduck Alert. All of it set up with CRDs, all of it using Horizon. You can easily create any application and customize it without any problem. Yeah, so that's basically how you use it. You vendor it in, and then you create your application, you define it however you like, and you can create basically human readable questions to your customers to allow them to customize whatever you want to do, and off you go, right? It's nice and easy.
Okay, so yeah, to be clear here, there is one container we run. It's the Blackduck operator, that's it. And it uses all that other magic, and it deploys everything Blackduck for you, and that's moving forward with this release we're coming out in the next, hopefully, few days or weeks, and Matt's gonna take over from here. But yeah, that's what I think the future of cloud native orchestration is you've got a single operator running somewhere in your cluster, and how you deploy that operator, there's a million different tools around that, but you've got to have something that understands your application. Whether or not you wrap it in Helm doesn't matter, but you need to compile it into your code too. Matt is going to do an interesting demo. We need a guinea pig.
All right, so has anybody ever seen a live demo crash and burn before? All right, so for everybody who didn't raise your hands, today might be your lucky day. All right, yeah, so does any company use Blackduck, or Blackduck by Synopsys out there? Okay. So for those of you who don't know, with Blackduck, you can scan your source code. It will find your open source vulnerabilities and give you some report that you can use to fix those vulnerabilities in your software. We built this application called OppSite. That's a cloud native application. You take Blackduck into a Kubernetes cluster, an OpenShift cluster, scan the Docker images that are in your cluster and look for vulnerabilities in those things. So I'm going to show you guys how we can deploy Blackduck and also Opsite in a cluster.
Who wants to be a guinea pig? Who wants to?
You're going to need to type a little bit.
Somebody.
Maybe use a shell. Perfect. All right, cool.
Do you know a little bit of Linux? Just a little bit?
No.
Perfect.
All right.
Just tell her what to type.
All right. Okay.
All right, does
You
it
want a Linux person or not?
You can definitely do the demo if you want.
Okay,
It's up to
fine.
you.
Go for it. Yeah. All right.
I know how to do my demo.
All right.
All she has to do is type. Type exactly what you tell her to type.
All right.
I think I might
Go
need
for it.
to
Go, yeah.
bootstrap this unless you have a terminal up already.
Does anyone else
Senthil.
want to go? Anybody
Do you have a terminal up already?
Yeah, he's got a terminal.
Yeah, go.
All right. I'll drive. Okay. I guess Matt, you're gonna have to drive.
Volunteer. I don't want to volunteer. So I work in sales. I'm fucking.
Это всегда мне немножко
All right, Jay. So can you go into that TMUX session on Kit Master?
клиенты пользуются какими-то
So we have this GKE cluster.
пользуются там опсы клиента или
So what we're going to do in this demo, we're going to take what we call the Blackduck Operator. We have that installed on a GKE cluster. It has a controller sitting in there with a couple of CRDs. We have CRDs for Blackduck and for Opsite. So we're going to use those CRDs to try and actually deploy our software. Try. All right. So, wait. Okay.
I'll just say that this hopefully will demonstrate how easy it is to run the Blackduck operator. We have someone who does not know anything about Linux or Blackduck.
All right, I can't see the right side of the screen from over there, so I'm gonna move over here.
What's that? Increase the font.
Yeah, it's pretty dark. I don't know if we can change the color.
Plus.
YAML, да,
All right, can you start? Sorry, what's your name? Camille. All right, nice to meet you. Matt. Can you type in PWD? Hit enter. All right. Can you do CD/opt? Sorry, CD space /opt. OP/OPT without a space.
Oh boy.
Senthil, can you help her out? All right, yeah, perfect. Hit enter. All right, can you do LS? Enter. So where are we at, Jay? Are we not on Kit Master?
Oh, yeah.
Senthil, can you get into Kit Master?
Synthil, get a control RSSH into that thing.
No, sorry, that's our fault.
Yeah. That's
Yeah, there you go. We definitely can't blame that on you.
Control R, man. It's in there. Okay, I gotta SSH into the cluster. Hold on. Don't you know how I structure everything? Okay, sorry about that. No, I'm talking to Synthil. Okay.
So we're trying to get into a place where we have a kube control pointed at our GKE cluster.
Oh wait, no, I had it in another TMUX. There you go. Sorry, we had you in the wrong TMUX session.
All right,
okay.
perfect. So now
Okay.
we're in the right place.
start
Let's
over.
pretend like we actually did it correctly.
Okay, here we go.
Can you do LS, enter. All right, now do CD space, start typing demo, and then hit tab. No slash, yeah.
Demo.
And then hit tab.
Hit tab.
Enter. All right, cool. So do an LS.
Enter.
Yep. So, in case you can't read that, we have several YAML files in here, which are definitions of CRDs. We have 3 CRD definitions for Blackduck and 1 for Opsite. So, can you type kube control? That's KUBECTL.
ECTL.
Space dash F.
Create.
Sorry, dash F. Like
create,
a minus.
No, create, type, create.
Dash F.
Create.
Space. Oh, I'm sorry.
Create.
Can you go back and do create dash F?
Delete.
My
Create.
fault.
Yeah.
My fault.
Yeah,
Sorry,
create.
everybody. Create dash F.
Yes.
You misspelled create. But
Oh.
you got a
Can't
W.
really read that. Okay,
Dash
now it's
F.
better.
Okay.
Dash F.
Dash F.
Got it.
No space.
No space between the dash and the F.
Okay,
Oh,
dash.
my.
Yeah,
It's someone
space.
else's.
No, you're
No,
doing
You're
good.
doing a great job.
You're doing
a
good.
great
Keep
job.
going. Keep going.
One dot.
Everybody, can we get a round of applause?
Yeah.
You're doing a great job.
Too late. You're
All right,
almost
can
there.
you do offsite.yaml?
OPS tab.
Just hit tab.
Hit tab.
Delete tab.
No.
Oh, no.
OPS,
Oh,
OPS,
hit-
OPS
Hit offsite.
and tab,
Hit
and tab.
tab.
Yeah.
Just hit the tab character.
No.
Tab.
OPS and tab. No
Oh.
IT.
I didn't hit offsite yet.
And hit tab.
No. it's
Oh,
I-
tab doesn't work,
Because I
Matt.
didn't do.
Tab doesn't work. Okay, guys. Sorry, demo's canceled.
Okay.
Apparently we don't have a tab key.
Okay, yeah.
Alright, can you
Hit
do it?
enter. Hit enter.
Okay.
Okay, we're back.
All right.
All right.
So what that did is that created an instance of that CRD in our cluster. So we just created an offsite. It was literally that easy.
Way to go.
Great job.
Okay.
Thank you.
Ladies and gentlemen, we have just installed the opsite connector.
Are we done?
All right. So what we could do now is we could do something like kube control git pods.
You want to cat that file out just so you can see
JB, don't steal my demo, JB.
Go ahead. Go ahead and cat it.
Git, G-E-T, pods, P-O-D-S.
It's
I'm
Senthil.
typing.
It's Senthil.
Okay. All right, Senthil dash N.
What is the namespace?
I think the namespace is demo offsite. There you go. Yeah. All right, cool. So that CRD just spun up 4 pods. That's an entire offsite installation. We have Perceptor, which is kind of our business logic. We have a Perceptor scanner pod, where we do the Blackduck scanner. We have a Perceiver, which talks to the Kubernetes API server. And then we have a Prometheus pod for our metrics.
And so you're now scanning every single application in your entire cluster for vulnerabilities. You just made the world a safer place. Yeah.
Thank you. I
job.
appreciate it.
Okay. Do we want to finish? How are we on time?
10 more minutes. 10 more minutes.
Do you want to just drive through the metrics and the rest
Yeah,
of it?
so
Okay.
that's how you can create an offsite. If you wanted to create a hub, it would be just as simple. We have different files for that because it's a different CRD. But now I'm going to show you all that stuff that I spun up about 3 or 4 hours ago, so you can see what it's like with all of its data there in action.
Okay.
You want to?
Yeah. Okay. Okay. Great. All right. Round of applause. She is scanning every container in her cluster for vulnerabilities using the Blackduck Operator against 3 different hubs that are running. Matt, Fennwick, what are we going to do now?
We are going to look at the offsite metrics.
Okay, yeah, so that's one of the coolest things about running the offsite connector, in addition to Blackduck, which some of you guys know about, is that it gives you it gives you metrics for every single event in real time regarding any of your security, any of the security scanning that's going on, and scan throughput becomes very important at data center scale, right? So, go ahead. You want to talk them through this?
Sure.
Yeah.
Just
Can
talk
everybody
loud.
hear me okay? Try and shout.
Yeah,
All
just
right,
shout.
So we have this is our core metric. We track this in Prometheus, and what this says is right now we have 95 images. Or sorry, this was spun up about 5 or 6 hours ago. There are 95 unique images running in our Kubernetes cluster, and that number right here is the number of unique images. This green number is images where as soon as we spin up, we check whether they've been scanned or not. So then we have a scan queue. So you can see that green is going down over time. And it took about 2 hours for us to scan all of our images. This red number, this red line down here, it's kind of the opposite of the green. That's images that have been successfully scanned. And so you can see that after about 2 hours, we finished all of our scanning. And then if anybody else spun up a new application in our cluster with new images we've never seen before, we would see a change in those metrics, but it looks like nothing happened because we were all here at the meetup drinking.
Yeah, so the significance of this is for those of you guys that haven't been scanning in from stuff in your cluster, shame on you. The significance, though, is that if you've got an OpenShift or Kubernetes deployment that's 100 or 200 nodes, you could have thousands, tens of thousands of containers running at any given time. So there's no way you could possibly know if you've scanned anything unless you have aggregated metrics across the entire data center, right? And that's what we give you.
Now I'm going to show you a metric that shows how many vulnerabilities the pods have. So when we started off about 6 hours ago, these are the pods where we didn't know how many vulnerabilities there were. And you can see as we scanned images, that went down over time. And then these other numbers are pods with 2 vulnerabilities. Let's look at this one up here. So this is pods with 4 vulnerabilities that Blackduck found when it scanned the image. And you can see that number is rising over time as we scan more and more. We have pods with 0 vulnerabilities, so we have a few that are good. We only have 21 pods with 0 vulnerabilities, 25 out of about maybe 100 total. So you can see that 75% of our GKE cluster actually has vulnerabilities that Blackduck found. And some of them, 1, 5, 34. Oh my gosh, we have 6 pods with 34 vulnerabilities. So this is the kind of thing, this kind of information that you can get by running offsite in a cluster.
The pods that have the 34 are probably the JavaScript. Probably the controller app, yeah.
I'm going to quickly try to bring up a hub UI so you can get an idea of what that looks like.
Can you say what you mean by vulnerability?
The CVs.
Yeah, so Blackduck has a knowledge base that consists of CVEs that are reported in public databases. And we take those and we match those up against open source component versions that we find in your software and use that information to say, you have these vulnerabilities.
So it's like snake or something.
Sorry?
It's like snake.
Snake, what?
Snake. It's like snake.
Oh yeah?
What's snake? Okay. Sure. I don't know what it is, so I'll happily agree with you.
So it's only public data and vendor, probably.
There is some proprietary data in the
Yeah, yeah, there's definitely proprietary stuff in here. All the stuff we're showing you is open source tooling we've built on top, but.
So this is what the Blackduck interface looks like. We could jump into, say, Hub Nginx. This is an image built out of Nginx. You can see that we think that there actually is high security risk in some of the components. There are license risks and operational risks as well. And so using the hub, you can actually dig into those vulnerabilities, figure out what components they're coming from. You have Alpine base layout, Alpine keys, and so on, and do something to mitigate those, or possibly just tell Blackduck to stop telling you about those. I think those are okay. So that's kind of information that you can get with Topside. And that's all I have for the demo.
Yeah, and in this demo, how many hubs are in this demo, Matt?
Oh yeah, we're running 3 hubs right now.
Okay.
So we're scanning in parallel against 3 hubs all at the same time.
Oh,
And just
yeah.
charting out those scans basically.
Yeah, so every single one of these hubs is going to be the annotate, as in addition to scanning all your containers, every single one of these hubs, because you know we're using multiple hubs to keep throughput very high on the scanning. The URLs for these hubs are all going to be published as annotations into your Kubernetes or OpenShift pods. Okay, so you can use the Kubernetes and OpenShift API to programmatically go through, find pods that are in violation of any of the Blackduck policies that you've set up. Moving forward, we're hoping to, in very short order, also have an ability to cascade policies between hubs. But essentially, this gives you an SLA that you can define yourself in terms of how quickly you want to scan everything in your cluster.
Where does your KB reside in your knowledge base? Do you make?
Jim, where does the KB live? I don't know. KB guy's here though. KB is going to be in the cloud pretty soon, but right now it's a day.
That's the Jay's not showing you, not showing you that. So offsite, more than just the metrics, but it also labels your pods and your images with the information, so you can have that information also at the cluster level.
Yeah.
Just through food control.
Yeah. So for you OpenShift people, your images will also be scanned so that you can, make it impossible for developers to do any useful work against images that have vulnerabilities in them, and in addition to killing their pods that they've just deployed. So we can scan both images and pods, and both have the same annotation. So you can essentially build your own programs on top of this if you're a security person, just using the standard OpenShift and Kubernetes clients. Or grep. What's that?
Can you make that bigger, Matt? Yeah.
Go ahead.
So for sites, for data center that do not have outbound connection to the internet.
They don't have what?
Internet
For
connection.
data center that do not have outbound
Oh,
connection
air gapped.
to the cloud.
Yeah. So Jim, what's the deal? Do we give people a KB? Do we give them an on-prem?
We can run KB on-prem and give
Yeah.
you like updates as we update our KB.
Yeah, so the KB does run on-prem, and absolutely, you can talk to Jim and he'll give you a USB disk with hundreds of petabytes of, I don't know how they do it, but they do it. So, yeah, you absolutely can do this, but otherwise, you're gonna talk to like Mothership and get all the vulnerability data from the KB. And it's the only outgoing connection you need. So typically what most customers do is they're running everything in an air gap and they make an exception for kb.blackducksoftware.com, right? And they can talk to that one thing. And the people that are super paranoid, Jim can give them a USB stick.
Any performance impact with the scan?
Performance impact? From whose perspective?
For the application.
It's not going to affect your application at all. So the way that OpsSite 2 forward works, OpsSite 1 actually used to run on a daemon set everywhere in your cluster, which means that if scanners went crazy, it could possibly bring down a node. In OpsSite 2 and forward, everything is pulled from a registry, okay? So there's an image that's running as a container, and we look at the URL for the image, we pull that guy down from the registry it's associated with into a thing called an image facade, and then from there, that's sent to the scanner. It's completely separate from your app. The image facade is pluggable, so if you didn't want us to talk to your registry, you could put a different image source, and that's a very easy thing to do, to write your own. So, but the default is, we just pull from your Docker registries, and we need credentials for that. Or we need to run co-located with the pod, so we could pull it, in which case you could possibly feasibly have a little bit of a performance impact on that node, but not much. What else? Is there anything else we want to talk about? Anything else that we want to show them? But why don't we show them how, before we go, why don't we show them how easy it is to list hubs? Oh, yeah.
So, what exactly is it scanning? Is it scanning the image definitions, or is it interrogating? So you said it's pulling it out from the registry. So it's basically going up the entire chain of the image.
It's scanning the whole image, Matt. You want to?
Basically, we will convert the image to a tarball and we will scan the whole tarball.
So you actually, so you're scanning the realized contents of the image. So
Yeah.
in case that image was compromised, for example, it's not like you're, if you get a compromised image from a bad registry or something, right? You'll actually capture that as opposed to just looking at the definition.
Absolutely, yeah.
Right, and the way we guarantee that is when we use the image SHAs to ensure that we're looking at the right thing. So when we look at the Kubernetes, we ultimately get the image information from Kubernetes. In Kubernetes, even if you give it something like, you just say Alpine latest, it will resolve that to a SHA. So then we use that SHA to pull that actual specific image. And if we can't guarantee the images are pulled, but if they are, we'll pull right one and scan them.
And so if you really wanted to go one deeper, we do have an example of how to actually scan a running container. We have an image facade example that we did for that actually will scrape contents out of the live running container so that you could figure out whether if some guy went and you ran Maven inside the application as part of the container definition and put a bunch of weird stuff on it. That's experimental. That's something somebody could run on their own if they wanted to. It's not a supported product yet. So just a quick back to the original thing, which was what does everything look like as we move forward into the future. You ship applications and you make them cloud native aware. You make the cluster aware of the application if you're a vendor, especially if you're shipping a security product. So somebody can do what Matt's done here, kubectl get opsites, and it shows the opsites that are running. You can see that we have 2 opsites running, the one that was spun up by our friend over here, and the one that Matt was running earlier to make sure all this works. We also have the 3 hubs that we're running against here, and you can just see that by running kubectl get hubs. So if you're an application vendor, this is a really good way to market your product and make it easy for people, administrators, to see where your product's running. We also run a SaaS, and it's pretty ugly when you get 100, 200, 300 applications running, and you have to list namespaces and hope that people name things properly in order to find different applications. That's the beauty of a custom resource definition, and why we prefer those as the way anybody defines a cloud native app. Yeah, that's it. And one other thing I'll mention is that in the way we realize these things is once you have a single operator running in your cluster that defines everything that you ship, your applications can work together. So in this case, if we were to spin up a new hub, immediately as soon as that hub's spun up, the offsite, there's the Blackduck operator that's running in the background would detect that new hub, and if it was labeled as a worker hub, it would send that worker hub to offsite so that offsite could use that for scans. So it gives you the ability to horizontally, to transparently horizontally scale any of your applications by just creating a natural kind of communication channel inside of the operator itself that can make other applications that you ship aware of other applications that you ship. That's it, yeah. I don't think there's anything else.